Hello everyone, today I'm going to deliver a lecture on axial force, shear force and bending moment diagram of frame. Okay, so let's start. So it will be mainly focus of shear force diagram and bending moment diagram of frame. Okay, so let's start. We can see the only math example of frame. Before going to the shear force bending moment diagram of the frame, just clarify some theory, which is the frame is the essential of several flexural member oriented in different direction and connected by rigid joint. Therefore, the axial force, shear force, and bending moment diagram of frame consist of the drawing of individual axial force diagram, shear force diagram, and bending moment diagram of each member, similar to beams. An assembly of the diagram for the entire frame using the free body diagram of each member. We will use the free body diagram. And the equilibrium equation, we know summation of f of x equal to 0, summation of f of y equal to 0, and summation of moment mz equal to 0 of each joint must be considered while drawing the member free bodies. Okay, so let's start. Here is our example. I'm just going to the example of 2D frame. So we can see here, here is an example. We can see that 20 kip load is a frame is given here, that point A point is a pin support, and it is height of the 12 feet, and 30 feet is a horizontal force, and B point is also horizontal force, and it is the 10 feet, and the vertical force we have been seen 20 kip, and 10 feet by 10 feet is given here. So let's start. We can find out this reaction at first. So we are going to the find out the reaction. We are taking the moment of point here. So we can see 30 into 6. This is the 30, and this is the distance, force into perpendicular distance, and 20 into 10. This is the 20, and perpendicular distance is to 10, and minus 5 into 12. Here is a 5, and 12 is a perpendicular distance, 6 into 6. And last one we can see 10 is into perpendicular distance into 6, and RB is distance is 10 into 10 into which is 20. So in this way you can find out the reaction of B, which is 30 kip. Is a 30 kip, it is the vertical force of the point of B. And now we're taking the moment at point B. This is the point B, we can see here. And in this way, now we are calculating at first 10. So I'm changing the color. This is 10 into minus 6. This is 10. We're taking the force into perpendicular distance is 6, and then second one is to 5 into distance is 12, and then we have taken 20. Here is a 20, and the distance is also 10, and 30. This is the last one. The force is 30 into 6. And RA, this is the moment of reaction in y direction, RA into 10, that is the distance is 10 into 10 into 20. And in this way, RAY, the moment forces we have been found 7. So now we are taking the summation of f of x, the horizontal forces, which is RAX plus 30. So we are taking the horizontal force only 30. Minus 5, this is the minus 5, as we are calculating, this is the reverse, that's why minus, and 10, this is also 10. So in this way we have been found the minus 15 kip. So we are not taking the 20 because we are just taking the x-axis, as we have been seeing the 20 is a y-axis. Okay, so let's start. We have been found. Here is a 7, here is a 15, here is a 13. We have been found 3 load, and the others load we have been seen here 20, 30, 5 and 10. So let's start from clockwise. So as we seen, this is the 30 in the axial load. So if we want to balance this, then we have to provide opposite direction of the load is 30. Okay, so we have already 10. We have been seen here, we have already 10 is applied load. So we are applying the counter load is 10, so it will be equilibrium. So now we are taking moment here. If we taking the moment here, that dash will be 10 into force into perpendicular distance, which is 10 into this distance. As we know that this distance is 6, we have been seen here. So we are taking the 60 kip feet. So now we are taking here in this way we are taking a moment here because we know the moment, the sign conversion positive moment is like this, and the another negative moment is sign conversion is like this. So we have been found the positive moment, that's why we are using sign conversion here. So as we have been found this 60, now we are using this as a counter port, that's why we are being used also 60 here this point. And 30 we have been found in previously, and that's why we are using the counter port is 30 here. And 10 we have been found this point, and we are using counter 10 for equilibrium purposes. And this 5 is already applied load, we have been seen here, the applied load is here. Okay, so now we have been seen here the 30 is given here, that's why the counter for 30 is also given to the gone there. And 60 kip feet moment is gone there, that's why moment is also gone there. As we have been seen here, the 5 kip is going to the x negative, and 10 also going to the x negative. That's why we are adding two value 5 and 10, then that will be counter of 15. Okay, so this for this 15 will be also counter of another node, which is 15, or another portion which have been seen here. And we have been found this is the 30, so 30 will be gone there also counter port. And we have been found the moment 60 kip feet, and it will be counter also 60 kip. The moment diagram also this way, and it is the counter for the opposite direction. 20 is given in question, that's why given in member applied already, that's why we are using the 7, as we have been already as 13. So if you use the 7, that will be counterpart of 20, and this is the 15, and it will be counterpart of the 15. So now this 7 will be gone there at this point or this member, and this 15 will be also gone there as this point we have been calculating here. As we have been seen here, the 30 is applied load, here is a applied load, so we have been already 15, so we need another 50 for counter this load. So in this way it will be equilibrium. So 7 is given here, and this is the 7 given. So these are the analysis of the frame. So if we categorize here for shear force, then the force member will be like that. I'm just erasing this value and trying to showing you. Okay, let's I'm changing color with red color. Okay, SFD here we have been seen here, the taking the 15, the 15 is gone there, and gone here, and 15 is gone also there, then it will be 30, so it will be 15 and another 15, this will be 30. So these are the this will be gone minus 15, and gone here, and this will be 15, this will be 15, and it will be 0. Okay, so let's see here this portion, this member. Okay, this member we have been seen 7 is gone upward, so we are taking the upward is 7, and we are having seeing the 20, so it will be downward of the 20, so 7 minus 7 and minus it will be 30, so 30 is downward, and this it will be 30 is given here, so it will be upward also, so equality upward, so it will be 0. So another we can see here this portion we have been seeing the 10 kip load is gone there, gone the left side, and this is the 10 load we have been using for equilibrium, and it will be 0. So in this way we are taking the 0. Okay, so now we are calculating the moment. So in this summarize we have been taking here, so if we seeing there, then the SFD diagram will be like this. I'm just drawing here for good perception. And BMD, how we'll get the BMD? So if we know the diagram of area of diagram of SFD, then it will be found BMD. How we'll get 15 into distance. So we know the distance is 6. We have been seen here. So 15 into 6 it will be 90. Okay. uh, uh, and 90, and 90 is positive part. This will be positive, and this is the 90 is negative, and it will be going down negative. This will be negative, so it will be 0 here. Okay. Another one we can see here, this is the 7, and it will be calculated at shear force into area of shear force. This is the 7, and distance will be this. How much distance we have been seen 10. So 7 into 10 it will be 70, so it will be going there like this. And this is the 30, 30 into 10 it will be minus 130. 130 into minus 7 it will be minus 60. That's why it will be going there. So we are drawing this here SFD is this like. Okay, we have been known the value of SFD 10, and area we have been known here the 6. So 10 will be 6, will be 16. So this will be positive direction. That's why we are taking here. It will be going there. So we are redrawing here the BMD for clearly understanding. This is the 90, and it will be goes 0, and this is the 70, and it will goes minus 60, and this is the 60, and this will be our final BMD diagram. So how will complete this SMT BFT of this frame. So here is some calculation. We have to calculate horizontal force or balance or equilibrium for equilibrium purposes, such as we have been taking 30, and we have to equilibrium 30. This is the balance. So we have to horizontal force and vertical force also. So this is the vertical force, and for horizontal force purposes this is the 30, this is the 10, and it will be horizontal purpose of 10. And moment we have to moment it will be equilibrium. That's we have found 30, and we have to equilibrium for purposes balance purposes we have been taking the 30. And we know the moment conversion, sign conversion. The positive moment we have been taking this way, and negative moment this way we have been seeing here. This is the positive moment, and this is the positive moment also. And negative moment sign we have been conversion we have been seeing like this way. So as we have been seeing, the calculation will be must be done with sequentially, like A B C D E F G, like this way. A B C D E F G this way, or A B. We have been seeing this is B, this is C D E F G H. This is the sequential. This is the sequential calculation we have been done. Or we can use this way, H G F E T C B F, but you have to must abide by the sequence. So if you have any force in joint, then the joint member will be separated like this way, joint member. We have been seen here the joint member here. Okay, so let's see another example. Here is the example for we have been shown the two member only two force 20 and 30 will be and 10. Now we are this is the point B, and this is the point A. So at first we are taking the moment of point B, 30 into 6. This is the 30 into 6, and we have been seeing 20 into 10. This is the 20. We are taking the moment this point A here. So this way 30 into 6, and 20 into perpendicular distance is 10. We have been taking 10, and minus 10 into 6 we have been seeing minus 10 is gone this way. The distance is 6. So in this way summation of Fi you are taking only vertical portion. So these are found the RB Y. This is the RB Y. You have been found 12.31. I will taking the summation moment Fy. You have been seeing Fy equal to 20.31. So this is the force, and 12.31 and minus 20. This is the minus 20, and we have been found RAY. In this way RAY will be 7.69. We have been found. And the summation of f of x, I have been seeing f of x into all the horizontal forces. We will take only all horizontal forces, not vertical. So this is the horizontal force, and this is the horizontal force. So we are taking 30 is a positive, is a rightward, and this is the leftward. That's why we're taking the minus sign. And RAX is equal to 20. This is the 20. This is the minus. That's why you are taking in the left to right. Okay, so now we're drawing the moment. Here we can see here 7.39, 7.69, 7.69 is gone, and the balance purpose we've been used the 7.69 also. This is the we have been seen. This is the 30. So we have been seen here the we are taking that this is the 20, and this is also 50. Okay. Okay, we are not doing there because we are calculating this way. Okay, we are not using this member first, so we will not calculating this member first. We will calculating, rather than we will focusing this calculation first. Okay, so we have been seen here how we'll get this, and this is the calculation. We have been seen that we have been taking the theta 63.45. So we have been taking all the calculation, and 63.45, I mean this way 26.5. This is another theta, and as we have been found here 12.31, this is the 12.31, and we have been calculating theta. This is the 11, which is goes the along the member, and this is the 5.51 the along the member, and we have been found this is the, and the theta is 16.45 as we have been calculating here, and found the moment is found this the load will be this way, it's 4.41, and this is the sign conversion. We have been use the sign, and it will be 8.81. Okay, so in this way we've been found there which is 11. This member is 11 member forces, and another we've been found 11 plus 4.41. That's why this is the 4.47. So 4.47 will be also added point this. That's why 11 and 4.4, this will be 15.47 for this in this direction, downward direction. And we can see here 3.45 we have been found, and it will be also 3.45, as we have been seen 5.5 is here, and this is the 8.5. So if we deduct 8.95 minus 5.5, then we will found the 3.31. This is the, we have been shown this point and this point. So this is the 5.5, and this is the 8.5, and for balance purpose 3.94. And the movement we will be taking here, and as usual we will be taking 13.9 keep fit. Okay, so let's see, this is the 11 we have been taking, this is the 11, and this is the 15.5 15.47, and coming here, and the 3.39 is here, and we have been taking the moment also 13.45. Okay, let's see. Here this is the 5.5, and it goes this word, and this is the 3.35, as we have been calculating all the calculations here, and it will be also 8.95. Okay, so we have been seeing here another portion, this portion we are taking this portion also. So we have been calculating it here, we have been seeing all the load is gone there as a 10 keep. So 10 keep is also applied this here, as we have been seen. Okay, and 12.5 is upward, and 7.39 is also upward, which is countering 20 keep, and we are also seeing the 13.3 is a downward, upward. 13.8 is a moment, not upward. We have been found here 7.60 keep, 60 keep is here. So 7.69 into 9 into minus 20 into 10 plus 60, in this way we will found 13.5. So the 30 is counter also, this 60 will counter also 60. So this 7.69 also counter 7.69, and this counter is 7.69. So 7.69 is countering this here, and we have been seen here the 30. So 30 is given, as we have been found is 20 is found here in the direction of right to left. So we have to provide only 10 load for balance purposes, as now we're taking the moment is here. So moment, if we calculating moment is 30 into how much, 30 into 6, and 20 into how much, it will be 12. So in this way it will be 60 keep fit. So that's why it will be calculated here. So now we're just using SFD diagram here. We have been found is 20 is given here, so 20 is given here, and is nothing here, and 10 keep we have been seen here. The 30 keep is given here, so 20 is given here, and 30 is gone the right side. So 20 it will be minus 10 if you calculate here, and nothing here, and this will be 10 as we have been seen here. 10 feet is gone right to left. So and another member we have been seen here. I'm just changing the color here. 7.3 is upward, 7.69 is upward, is gone here at first. 7 upward and nothing here, and it will be downward how much, it will be 20. So 7.69 and minus 20, it will be 12.31, and this is gone down, and it will be 0, as we have been seen here that 12.31 is here. Okay, so let's see this portion how much we have been seen. 5.51 is gone the right direction, it will be 10. 5.5 and nothing is here, and the applied load is we've been found 10, but in the, if we divide in components, so we've been seen here 8.91. So 5.51 is gone here, and 8.91 is downward, then it will be found 3.3. So 3.3, and in this way we will go on to 3.3 and found 3.3, it will be 0. That's why you have been found as SFD diagram is here. So now we're calculating the bending moment. We know the amount. We're just changing the color. We know the area of SFD is called BMD. So how much? 20 into how much, it will be 6. So 20 into 6, this way 20 into 6. 20 into 6 is 120 keep, and how much, it will be 10 into 6. 10 into 6 into 60, so 60 minus 10 into 6, it will be also 60. Okay, so this will be goes down here. Sorry, it will be gone down here, and 60 is also gone down here, as we have been seeing here. The 60 is already applied here. So now calculating this portion, we are seeing 7 into 6, 9 into area, how much length is 10. So it will be as already 60 is given here, so we have been found is 60 keep fit is, that's why we are taking the 60, and now it will be adapting 7.69 into 10 will be 66.9, and 60 plus 66.9, it will be 137. This is the 137, and minus will be this portion, which is to 12.31. So 12.31 into 10, so it will be deducted with 137, and 137 minus 123, it will be 14. So 14, and it will be minus, as we have been found here 13.8, it is almost 14, so it will be one is there. So in this case we have been calculating here the same. We have been found 30 is given in the calculation. We have been found the moment is 13.9. The 13.9 is found in here, and the moment with the 36.9, we have been seen 5.5 minus in this length. We have been found this from this calculation, and found in this way there will be moment diagram. So let's see another example. As we have been seeing, it is taken from Professor Dr. Anam sir. Draw the axial force, shear force, and bending moment diagram of the front edge loading shown. We have been seeing that two type of example. So firstly, we have been seeing this example. So we have been shown that DOSI. We have been using the DOSI as we have been seen in previous class, how we will calculate the DOSI. Sorry, here is the example we have been seen in previous classes. How can we calculate the dou c? This is the dou c. So this is the formula we've been used. Sorry, this formula we've been used for calculating dou c. Okay, so let's see how we'll calculate this. Okay, so dou c we have been calculating in this way and found 0, so it is statically determinate. So we're taking the summation of moment is 0 as 10. We have been taking 10 into 10 and minus HA. This is the HA, and minus 5 is here, and found HA equal to minus 5. This is the HA point. We have been taking minus 5. And summation of moment we're taking the moment is here 10 into 10, so 10 into 10, and this is the one portion and this is the another portion. So now we're calculating this portion. So at first 10 into 10, this is the 10 into 10, and BD, this is the B of D, vertical of D, and it will be 15, and this is the 15 length. And in this way count B vertical D is 6.69, and we're taking the summation of Fy. After the calculation we have been here BA into BD, and BD will be known 6.67, and it will be BA also. So now we've been seeing here the reaction 6.65, 6.67, and 6.67 also the on the point of D. And AFD, how we calculate as reaction is going down, 6.67 is we've been seeing here 6.67, and goes down, and we've been seeing here how much is 6.67, also 6.67. How we calculate the SFD? As we have been found 5 feet. This is the 5 feet. I'm just changing color. We're taking this is the 5. How calculate this is the 5, so we are taking the shear force is 5, and this portion I will calculate. This portion is we have been taking the vertical which is 6.6 in vertically, that's why it will be applied here vertically 6.6, and we've been taking the another is 5. We have been already found shear force 5 is 5, that's why 5. And I will calculate the moment as we have been shown. 5 into 10, the area of shear force will be bending moment. So 5 into 10, 10 is the distance length of the this length, that's why it will be 50, and this is the 50. And we have been seen this load. How will calculate 6.65 into 15, and it will be divided by 2 load, this load and this load, that's why divided by 2, that will be 15. So 15 will be goes left side, and another 15 will be goes right side. And we've been found the 5, and the similarly and length is 15, so we'll calculate the 5 into 10, it will be 15. Okay, so we have been calculating here. So now we'll see this picture. So we've been seeing we are calculating those in the same way as we've been seeing here. Now we'll calculate the BMA and horizontal and in this way MA equal to 5H. As similarly MD equal to 5H, and we are taking the MG, and in this calculation we have been getting AC into 10 into BA into 7.5 into MA. And after the putting this calculation, and we have been found this calculation 5A into 10 minus into 7.5, and AC equal to 1.5 into B. And also we can calculate the this portion, and we are calculating this portion and found HA into 1.5T. Now we will calculating summation of Fy, and we have been found BA BD equal to 0, and found BDA equal to BA, and summation of F of x we have been found FA equal to this way, and 1.5 equal to this way, and found this way, and finally we have been found BA. So BD equal to B equal to 3, HA equal to 1.5 equal to H, and HD equal to 1.5. So now we are putting all this value in here. So in the point of B we have been seeing here. Here we can see here 3.35, the reaction is here, and 3.36 is also the another point is we have been seeing here, which is called is D point. This is the D point, and we can also given the 5 in the x-axis, and x-axis is the 5, and here is the SFD. If we are seeing here 3.35 is given is here, and 5 is and already we have been found. That's why it is taking the downward minus 5 and 3.35 in left side on the diagram. And we've been seeing the SFD also in keeping is given here. This is also I've been shown at first in the axial force diagram. So axial force diagram, we're taking this point, or 3.37, this is the 3.37, and 5 we have been taking this is the 5, and this point will be 5, and 3.37 is also there. Okay, so how we'll get the 5? This is the 10 and this is the 5, so it will be ultimately 5. Okay, so now we're taking the shear force diagram. So I'm just changing color here. So SFD diagram, how will draw the SFD? This is the 5, so this 5 is gone here, and 3.3 we have been found. 3.3 is here, so it will be applied this in vertically, so that's why we have been taking vertically. And 5 we've been seeing that this member is perpendicular to 5, that's why we are taking the 5. And in this way, the bending moment we can calculate 5 into 10. We have been seeing the length is also 5 into 5 into 10. That's why 5 into 5 5 into 5 we have been seen here minus 5 and minus 5. So as we have been seeing, this is the what I will say. This is the hinge point. That's why we are taking here minus 5 into 5 is 50, and plus 5 into 5 into 50. And in this way we can calculating also there. It is also hinge. So we have been hinge is applied this portion. That's why this is 15 and this is also 15. Okay, we can see here the clearly describing here the calculation is also given. The hinge is given here. That we have been we are calculating very broadly here. If you want, you can see here another calculation is for 3. You can see here the number 3, the calculation is here. Okay, thank you everyone. If you have calculated, thank you everyone.